we're going to talk about some transformations now of my square root functions. We had this similar form. Actually, we had it in what we called vertex form of a parabola. So remember how back when we did quadratics, we said that vertex form of a quadratic, f of x equals a times x minus h squared plus k. Now, why was that important? We said that hk was my vertex, right? That's what we said. We said hk was my vertex, and we said it's kind of confusing because minus h and plus k, right? So the actual h was the opposite sign, but the k was the same sign, right? It sounds confusing when we had it in a form kind of like this box is. So for example, if you had f of x equals 3 times x plus 2 squared plus 7, we said, well, actually, that's going to be negative 2, positive 7 for my vertex, right? We also said that this a value tells that it's concave up, right? That the parabola opens upward like this. As x gets bigger, y gets bigger is the key right there. All right, so those are what h, k, and a meant for a quadratic, right? Of course, backwards on all this, right? So this 3 is going to tell you it goes like this, right? If that was a bad parabola, Miss Mickle, parabola, right? If instead I had f of x equals negative 2, x minus 5 squared minus 3, of course, that's going to be 5, 3 as the vertex, and that's going to tell me the quadratic opens downward, right? As I go right, I go down is the key on that one. So that was all for my quadratic. Miss Mickle, we're talking about square root functions. No. But notice the very similar things. And really, if you remember, that similar situation happened for my absolute values, right? We actually had it in this form for my absolute values, right? Or we had, let's call it just g of x to talk about them, right? So similar situation for those. hk was your vertex, and then a is positive, opened up, a is negative, downward. We also talked about how it talks about the stretch. The bigger it is, the kind of taller, the more stretched it seems, versus if it's closer to a fraction, that would be wider, not whiter. Similar situation here, a horizontal translation. Notice it says h units right if h is positive. Again, it's looking at x minus h. So that's going to mean right if it's square root of x minus 2 is going to be right 2. If a is negative, x plus 3, it's going to be left 3. Right? We're still going to move it left absolute value of h, so 3 units. The domain is always going to be always, always, always. We already saw this. I set up whatever's under that square root as greater than or equal to 0. I solve it. It's going to be x greater than or equal to h. The vertical translation, right? So the square root of x, if you have it on the outside, plus 3 is going to be up, but minus 5 is going to be down, right? We also then know, again, it's going to depend upon a, so let's just pause on this for just a minute, right? If a is negative, it reflects across the x-axis and looks like this. If a is positive, it's going to look like this, right? So this is a is positive, and this is a is negative, right? Which means, right, if a is positive, then the range is always greater than or equal to k. It's here or above. If a is negative, then it's always less than or equal to k, right? Again, k is going to be the y-coordinate of this point on your radical function. The other things we talked about as well, that if the absolute value of a is greater than 1, that's going to mean, of course, if I have like 2 square root of x, or if I have negative 2 square root of x, similar thing, it's going to be stretched vertically. It's kind of going to look taller. Versus if a is a fraction, right, whether it's a 1/2, whether it's a negative 1/5, right, whatever it may be, it's going to be what we call compressed vertically. It's kind of going to look squashed toward the x-axis, right? And so we'll take a look. We can really plot some points to get a better visual of that as well. So let's take a look at what that might mean. Describe and graph. Right? I actually am going to ask that we use appropriate terminology, which means we're going to use the word translation and stretch and reflected. This is going to definitely come in handy as well next year as we continue to work with these. So this inside is always going to affect your x-coordinate. So I'm going to say that the graph is translated. Translated is going to mean shift, right? Shifted or moved, right? But the word I want to make sure that we use is translated. That's the technical terminology. And so we want to make sure we know how to use that phrasing as well. And so we can expand our vocabulary. So translated, 2 units. Again, that minus sign means we're going to go right. It's always the opposite of the inside. And notice the +5 on the outside, you're still going to be translating. So you can translate that +5 is going to be up 5 since on the outside, so up 5 units. What I'm going to do is find that point then. I was at the origin, right? I was right here, and I go over 2, and I go up 5. 1, 2, 3, 4, 5. So right here. Right? That's going to be, that's going to be my new point. That's where I'm going to start. And since there's no a, right, there's no value of a here, we know that that means that, of course, a equals 1, which means that the shape is the same. So I can think of this as 0, 0, and you go over 1, up 1. And then remember how if this was the order of the 0, you'd go 1, 2, 3, 4, up 2, right? And that's how I can really make sure I get the appropriate shape on this graph to get that exact same square root function. So that's because I have an a value of 1. I can truly go over 1, up 1 versus over 4, up 2. Those are the points you're thinking about. You're thinking about on the old graph, 0, 0, and 1, 1, and 4, 2. But things, of course, have been shifted over. Describe and graph this one. So I have a few more transformations. This one actually has got a lot. Translated, left 3 units. Right? Remember how that's the inside is always the opposite. And actually, I'm gonna go to this one just for a moment. We'll come back to that one in just a sec. This one's just got 2 things. So I want to take a look at it first. Translated, left 4 units. Again, that plus sign is going to mean left. And stretched vertically. Right? Stretched vertically. It has a scale factor of 2, which means everything is twice as far. Right? What does this mean? This means every point is twice as far from the x-axis, right? So everything's twice as far from the x-axis. So if I take a look at that, notice I first move left 4. I don't move up at all, so I'm still right here. Notice if I move twice as far from the x-axis and I'm on the x-axis, I'm just where I started. But typically my point would be right here, 1 over 1 up, and then 4 over 2 up. That's typically where I would go. Everything is twice as far away. I was 1 up, now I'm 2 up. I was 2 up, now I'm 4 up. Right, so we're going to stretch that vertically, and it's going to look like this. If you're feeling real crazy and really want to make sure it's going on too, you could have said 4, 5, 6, 7, 8, 9 would have been right here, right? I counted 9 from my -4 to get to that 5. And then I went up 3 from that 0, right? Because that would be the next square root of 9 would give me 3. But I'm going to go twice as far away, so I'm actually going to go up to 6 right there. So we can really make sure that this graph gets a nice curve on it. We can really see the definite stretch up versus this graph, right? That's what it's stretching from. You can kind of imagine it being pulled up away from the x-axis. Right? I wanted to take a look at that one first before I get back to this guy, because this one's translated left 3 units and down 1 unit, and right, and then it's stretched vertically with a scale factor of 2 and reflected across the x-axis. Whew, so many things. How did that so many things? Now, what did I know that from? Left 3 units is the inside piece. Right? Then, of course, I have down 1 unit. That's this guy on the outside, minus 1. Then I know it's stretched vertically because that 2 is greater than 1. Right? And, of course, reflected is going to be this negative out front. That's where I got each of those pieces from. Right? The key is going to be knowing where to start. And really from there, you can kind of plug in numbers if you want. We're going to start right here. Left 3 units, so at negative 3, and down 1, negative 1. I'm going to plot negative 3, negative 1. Now from there, you really might just want to plug in a T-chart. You plug in negative 3, negative 1, then so just plug in the next few numbers. You plug in negative 2. Right, you plug in negative 2, you have negative 2 times the square root of negative 2 plus 3 minus 1. That's the square root of 1. So 1 times negative 2 minus 1 is negative 2 minus 1 is negative 3. Now, if we just take a moment and recognize, wait a minute, Miss Mickle, if I plug in negative 1, I'm going to get the square root of 2. And that's kind of messy. So maybe I don't plug that in. We can actually use the same idea. Notice if I plugged in negative or 0, it won't be nice either. Because I really want to go 1, 2, 3, 4 units away. I really want to use this 1. So I'm going to challenge you to say, let's put in 1 instead. Let's see, negative 2, square root of x, so 1 plus 3 minus 1. Negative 2 times the square root of 4 minus 1. Negative 2 times 2 minus 1 is negative 5. Right? 1, 2, 3, 4, 5. Right? And can really get that challenge on it. Now notice, this is the first point that I drew. Right here, this is the first point that I drew. That's the furthest down it goes. From there, it just has this nice square root curve to it. The same curve we've seen in the other ones, that square root curve. Notice you'll see as well that everything is twice as far down, right? This was 2 units away and now is 4 units away. Again, I'm thinking just like we did here. This one was 1 unit up, was 2 units up, was 3 units up. Whenever I was 1 unit away, 4 units away, 9 units away, right? So those are the points, the key points you're thinking of and how those adjust. Really practically to make sure we're doing that is I would like you to find that first initial point. It's always going to be how far over have I gone from the x direction? How far up or down have I gone in the y direction from that 0, 0, right? So whenever I move left 3, I'm at negative 3 and down 1, I'm at negative 1. And then